Okay, so this is page 1 of the Chapter 10, Part 1 packet. And we're going to go over quadratic functions, how to graph them, and what they look like. So a quadratic function's a nonlinear function that can be written in standard form. And the standard form is y equals ax squared plus bx plus c. This should look familiar because that's exactly what the quadratic trinomial looked like. Now, when you graph this quadratic function, it will have a U-shaped graph called a parabola. And in this lesson only, we are going to graph where y equals ax squared plus bx plus c. But in the ones we're doing, we're letting b equal 0. So this whole term goes away. So it's actually going to look like that. And you will see that when b equals 0, that these graphs always have an axis of symmetry that's x equals 0, and you will learn what an axis of symmetry is. So first, I'm going to graph for you the parent quadratic function. The parent quadratic function is y equals x squared, or it's f of x equals x squared. Okay, now to graph this, we're going to make a table. And we are going to choose a domain. And from that chosen domain, we're going to derive the range. So these are the points I'm picking. Now, if I plug -2 into this, so I'm going to find f of -2. It's going to equal -2 squared, which is 4. F of -1 is going to be -1 squared, which is 1. F of 0 is 0, f of 1 is 1, f of 2 is 4. Notice there is symmetry in the numbers because there is symmetry in your parabola. So graphing these points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. When I graph these, I'm careful to make a U-shaped graph, trying to avoid something that looks like this, which is absolute value. And I have graphed the parent quadratic function, and that U shape is called a parabola. Now, the point at the very bottom, right here, the lowest point, that is called the vertex. Now, when the parabola faces upward, the vertex is the lowest point. When it faces downward, the vertex is the highest point. And through the vertex, there is a line that's called the axis of symmetry. And the axis of symmetry is the line through which every point on the parabola is symmetrical. So the distance from this point to the line of symmetry is the same as this point to the line of symmetry. If you were to fold your parabola that's on a piece of paper and put the fold at the axis of symmetry, the two lines of your parabola would line up perfectly. Okay, so this is the parent function. And here, we'll just review that the lowest or highest point is called the vertex, and that the line that passes through the vertex and divides the parabola into two symmetrical parts is called the axis of symmetry. You will see me abbreviate it as AOS, the axis of symmetry. Okay, now for today and today only, we are doing quadratic functions where b equals 0. And when b equals 0, our axis of symmetry is always x equals 0. You will find out why in the next lesson, but for now, just know that today our axis of symmetry is always going to be x equals 0. So to graph a quadratic function, you always start out by finding the axis of symmetry. When you find the axis of symmetry, you're finding the x value of the vertex, because if the axis of symmetry has to go through the vertex, that's the x value of your vertex. You then use the x value of your vertex and plug it in to find the y value of your vertex. Therefore, you're finding the vertex. Then we make a table of values and we put the vertex in the middle because we take advantage of the symmetry. And once we've made our table, we then graph points to connect it. So we're going to actually graph this equation, y equals 2x squared. So because b is 0, the axis of symmetry is x equals 0. So to find the vertex, I plug in 0 for x to find f of x or y. So in this case, when x is 0, y is 0. So my vertex is 0, 0. But now I'm also going to pick some other values. I pick values to the right, values to the left. And I take advantage of the symmetry. So if I find f of 1, that means I plug in a 1 where I see an x. 1 squared is 1 times 2 is 2. And then I find f of 2. And 2 squared is 4 times 2 is 8. I take advantage of the symmetry, right? And I graph these points. So -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. And again, I try to make the most U-shaped graph I can. And I have now graphed another function. So again, you're going to go through these steps. You're going to find the axis of symmetry. And in this case, when b is 0, x equals 0. Next class, we will learn there's actually a formula for the axis of symmetry. It's x equals -b over 2a. And because I keep telling you b is 0, if x equals 0 over anything, x is going to equal 0. Once you find the axis of symmetry, you then find the vertex, because the axis of symmetry gives you the x value of the vertex, which you plug in to find the y value of your vertex. You make a table, put the vertex in the middle, and you find the other values. Okay, so we are going to turn the page. And let's see. Okay, so this now says what we're going to do now is we are going to compare our graphs to the parent function. So we already did number 1, and I should have pointed it out, and I didn't. But when we graphed y equals 2x squared, it kind of looked like this. It was very narrow. But when we did the parent function was a little more like this. So we would call, when you move in like that, we would say that the blue parabola is stretching. So what made the blue parabola become more narrow or stretch? And the answer is the 2. So we're going to go over the types of transformations. So now, these rules are the same you've learned before. When the absolute value of a is greater than 1, it's a vertical stretch. And with a parabola, that means it becomes narrower. Okay? Now, to find the vertex, we know that when b equals 0, the axis of symmetry is x equals 0. So we know the x value of our vertex is 0. To find the y value, we do f of 0. And in this case, the y value is also 0. So for the next one, again, b equals 0. So our axis of symmetry is x equals 0. The x value of our vertex is 0. When we plug in f of 0, negative times 0 squared is still 0. So the vertex is 0, 0, but now I notice a negative sign. So when a is negative, that means we're going to have a reflection. And a reflection of a parabola is a downward facing parabola. Okay, for the next one, again, b equals 0. So the axis of symmetry is x equals 0. So the x value of our vertex is 0. And when we plug in f of 0 into this one, we also get 0. But now this one, a is in between 0 and 1. So therefore, this is going to be a vertical shrink. And a vertical shrink in a parabola becomes wider. Where a stretch is narrower, a shrink is wider. Okay, for number 4, this is going to be the first time our vertex is not going to be 0, 0. Although the axis of symmetry is x equals 0. So the x value of our vertex is 0. When we plug in f of 0, we get 0 plus 2. So now we have a vertex of 0, 2, which means instead of starting here, we're going to start here. So that is a translation up 2. Now, we shouldn't be surprised that it translated because translations usually occur when we add or subtract. And if we look at number 5, we're subtracting. So our vertex is 0, negative 3, and it would look something like that. So number 5 is also a translation. So now I want you to try to finish the page, see if you can state the vertex, and see if you can list the type of transformations. So stop the video and start it again when you're ready to see the answers. Okay, so for number 6, again, my axis of symmetry is x equals 0, so the x value of my vertex is 0. When I do f of 0, I get 4, so my vertex is 0, 4. So that means there's a translation. And I notice that a, the absolute value of a, is in between 0 and 1, so this is a vertical shrink. For the next one, again, my axis of symmetry is x equals 0 because b is 0. So if I plug in f of 0, I get negative 5. So my vertex is 0, negative 5, which means this is translated because it's a translation unless your vertex is 0, 0. It's also a reflection. Why is it a reflection? It's a reflection because this is negative when a is negative. And it's also a vertical shrink. Why is it a vertical shrink? Because a is in between 0 and 1. Finally, the last one, my vertex is 0, 2, and this is a vertical stretch. Why is it a vertical stretch? Because the absolute value of a is greater than 1, because 3 is greater than 1. Okay, so now let's turn the page. And now, so this is showing you stretching and shrinking. So when a is greater than 1, we know that's a vertical stretch. And when it stretches, it gets narrower. So that is your stretch. This is the parent function. Okay, so the red is stretching from the parent function. And this is the shrink. So when a is in between 0 and 1, it shrinks. And when it shrinks, it gets wider. So remember, a shrink gets closer to the x-axis and a stretch gets further away from the x-axis. Okay, so now let's look at, these are showing you reflections. So if it's a stretch with reflection, it looks like this. So it's still narrower, but it's facing upside down. And if it's a shrink with reflection, it looks like this. It's wider, but it's upside down. And what makes it upside down? A is negative. Okay. And then lastly, we have the translation. Now, an upward translation happens when you're adding. So when you're adding plus c, when c is positive or greater than 0, that is a upward translation. Something like this. And when c is a negative number, when you're subtracting, you have a downward translation. So something like y equals x squared minus 5 would look like that. And y equals x squared plus 5 would look like the blue term. Okay, so that's the end of this video.